Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a conical duct having shape of a frustum of a cone which has been intersected by an auxiliary inclined plane inclined at an angle of 30 degree with respect to the horizontal plane and perpendicular to the vertical plane. And this AIP, it passes through the corner of the base from the left hand side over here. And here we have got the base of this conical duct. It happens to be 60 millimeter, while the frustum of the cone is obtained as another auxiliary inclined plane. It is parallel to the horizontal plane. It is going to cut this cone at a height of 42 millimeter from the horizontal plane. So we have got the base of the cone equal to 60 millimeter. Height of the cone happens to be 75 millimeter. So this way, this cone has been cut by two cutting planes. So with this information, we are required to obtain the development of the lateral surface of this truncated cone. So let us first of all evaluate the top view and the front view projections corresponding to this conical duct or the truncated cone over here. So as the observer is going to look at this cone from the top, so the circular projection we are going to obtain onto the horizontal plane in the top view projections over here. So now we know that the diameter of the base of the cone happens to be 60 millimeter. So we have marked this diameter of this cone as it is obtained as a circular projection onto the horizontal plane as 60 millimeter. So now we have divided the circular projection corresponding to the base of the cone into 12 equal parts such that the included sector angle for each one of these parts will be equal to 30 degree. So now we have got the representation of 12 points of the base onto the horizontal plane over here. Now we have also marked the apex point, that is point O over here. Now having obtained the top view projections corresponding to this conical duct, now we need to obtain the front view projections corresponding to this truncated cone over here. So the 12 points of the base, they have been projected onto the XY reference line into the elevation projection view over here. Now we also know that the height of this cone happens to be 75 millimeter. Now once we mark the height of the cone is equal to 75 millimeter, so the apex point O dash will be evaluated over here. So the moment we obtain the apex point O dash, now we can join the apex point O dash with the base over here. So to begin with, we have joined O dash 1 dash and we have joined O dash 7 dash over here. Now we can check as this auxiliary inclined plane parallel to the horizontal plane, it is going to cut with the cone at a height of 42 millimeter over here. So at a distance of 42 millimeter, we have drawn an auxiliary inclined plane so that we are able to obtain frustum of the cone over here corresponding to this AIP cutting plane which happens to be parallel to the horizontal plane. So now the projections corresponding to the top face of this frustum of the cone, we have to obtain into the top view projections as well. So now once we draw projections from these 2 points over here, now we will be able to obtain the top view projections corresponding to the top face of the frustum of the cone over here into the top view projections. So now we have also joined apex point O dash with the remaining 10 points of the base over here. These slant generators corresponding to the base points 2 dash 12 dash 3 dash 11 dash 4 dash 10 dash 5 dash 9 dash and 6 dash 8 dash. All these 10 slant generators, they happen to be apparent lengths of the slant generator, whereas O dash 1 dash slant generator and O-7- slant generator. These two slant generators happen to be true length slant generators. Why? Because the apparent length projection corresponding to the slant generator O1 and the apparent length projection in the top view corresponding to the slant generator O7, both of these apparent lengths, they happen to be parallel to the vertical plane. So in the front view projections, O-1- and O-7- generators, they are projected as true length projections into the elevation projection view. So now we know that there is second auxiliary inclined plane passing through the leftmost corner of the base, inclined at an angle of 30 degree with respect to horizontal plane and perpendicular to the vertical plane. So this cutting plane passes through the left corner of the base of this particular cone. So we have got intersection of this auxiliary inclined plane with all of the 12 slant generators of this particular cone over here. So now we know that this cone has been intersected at two places. At the top, it has been intersected by an AIP which happens to be parallel to the horizontal plane. So we obtain the frustum of the cone. So this portion of the cone has been removed over here. Similarly, this cone has also been intersected by another auxiliary inclined plane inclined at an angle of 30 degree to the base, and this AIP passes through point 1- of the base over here. So now we know that this is remaining portion of the solid, and we are required to obtain the lateral surface of this particular truncated cone over here. So in order to obtain the development of the lateral surface of the truncated cone, so to begin with, we have to draw the development of the uncut cone over here. So we know that, as we have discussed, O-1-, it happens to be the true length of the slant generator. Similarly, O-7- over here, it is again the true length of the slant generator into the elevation projection view. So with these two radii which are equal to each other, we are going to open the compass from point O, mark the radius O1 is equal to O-1- over here. So the true length of the slant generator, this radius we have marked it out over here. And now with O as center, O1 as our radius, we have drawn an arc in such a way that onto this arc, all the 12 points of the base, they will be located over here. So through point 1, now we are going to measure distance between points 1 and 2 over here, because we have already discussed, we have divided this circular top view projection into 12 equal parts, so that included angle of each sector happens to be 30 degree. So distance between 1 and 2 will be same as distance between points 2 and 3 and so on. So we'll measure the distance between points 1 and 2 over here. And now with 1 as center, radius is equal to distance between points 1 and 2, 12 arcs we are going to draw, so that all the points of the base, they have been located onto this arc which we had drawn corresponding to the true length of the slant generator, that is O-1- radius. Now having obtained all of these 12 points into the development surface view, now we are going to join point O with all of the points of the base. So in all, you can see 12 slant generators we have been able to project onto the developed surface view over here. So now we know that this auxiliary inclined plane, which is inclined at an angle of 30 degree with respect to the base, passing through the point 1- of the base over here. So this point, it has intersected with all the 12 slant generators of this particular cone over here. So let us mark out these 12 points of intersection as they are obtained by intersection of this auxiliary inclined plane with the slant generators of the cone over here. So we'll find that the intersection of the slant generator O-1- with this AIP happens to be 1-1-. So this is first point of intersection. whereas 21 dash and 12 dash, these 2 points of intersection, they are obtained by virtue of intersection of the AIP with the slant generators O dash 12 dash over here. Similarly, the points 31 dash and 11 dash, they have been obtained onto the apparent length of the slant generators O dash 3 dash and O dash 11 dash respectively. Similarly, next 2 points of intersections 41 dash and 10 dash, they have been obtained on the apparent length of the slant generators O dash 4 dash and O dash 10 dash over here. Similarly, the points of intersection 51 dash and 91 dash, they have been obtained by virtue of intersection of the cutting plane with the slant generators O dash 5 dash and O dash 9 dash over here. Next 2 points of intersection 61 dash and 81 dash, they are obtained on the apparent length of the slant generators O dash 6 dash and O dash 8 dash over here. And finally, the last point of intersection corresponding to the first auxiliary inclined plane, it happens to exist at point 71 dash onto the slant generator true length O dash 7 dash over here. So this way we have identified 12 points of intersection. Out of these 12 points, the points 11 dash and 71 dash, they happen to lie onto the true lengths of the slant generator, whereas the remaining 10 points which are appearing as 5 paired points over here, so they are appearing onto the apparent lengths of the slant generator. So corresponding to these 10 points, now we are going to obtain the true length of the radii over here. So now the distances O dash 21 dash, O dash 12 dash, this is the apparent length radii. So if we draw a horizontal projector from the points 21 dash and 12 dash onto the true length, so this point that we obtain on the true length, and if we measure this distance O dash 22 dash, O dash 12 dash, so the true length radii corresponding to the points 21 dash and 12 dash, they have been obtained. Similarly, we have obtained the true length of the radii corresponding to the points 31 dash and 11 dash. Once we transfer these two apparent length points onto the true length over here, we can project on the true length either on left side, we can project onto the true length either on the right hand side. So in order to avoid congestion of points on one side of the axis, few points we are going to label on the left hand side, few points we are going to transfer onto the right hand side true length over here. So 31 dash and 11 dash, they have been transferred using this horizontal projector line onto the true length at this particular point over here. So the radius will be O dash 32 dash, O dash 11 dash over here, corresponding to the points 31 dash and 11 dash respectively. Similarly, these 2 points 41 dash and 10 dash, again they happen to lie onto the apparent length of the slant generator. So now we have transferred them onto the left hand side true length, that is onto O dash 1 dash over here. So now the point which we obtain over here, this will be 42 dash and 10 dash. So now we will be measuring this distance O dash 42 dash and O dash 10 dash over here. So next 2 points of intersection, they are 51 dash and 91 dash, obtained onto the apparent length of the generator O dash 5 dash and O dash 9 dash. So now again we are going to transfer these 2 points onto the true length at this particular position over here. And now if we measure this distance, we'll be able to obtain the radii corresponding to these 2 points of intersection as O dash 52 dash, O dash 92 dash over here. Now corresponding to 61 dash and 81 dash, again we have transferred these 2 points onto true length on the left hand side. So this point of intersection with true length will provide us with the radii O dash 62 dash, O dash 82 dash, whereas 71 dash already happens to lie onto the true length over here. We have identified the true length radii corresponding to these 12 points of intersection over here, in the elevation projection view. So let us plot all of these 12 points into the development surface area over here. So we know the distance of point 1 1 dash, which happens to lie onto the true length O dash 1 dash over here. So this point 1 1 dash and 1, they will be coinciding with each other. So we have plotted 1 1 over here and 1 1 on the other side of the developed surface over here. Now the next 2 points, they happen to be 2 1 and 12 1. So onto this elevation projection, we have got the apparent length radii. Now we have obtained the true length radii over here. Once we measure the distance O dash 2 2 dash and O dash 12 2 dash corresponding to this point and O dash point over here. So once we measure this distance, now onto the true length of the slant generators O2 and O12. If we mark the same distance over here, so the 2 points 2, 2 and 12, 2 will be generated over here. Similarly, corresponding to the next 2 points, that is 3 1 dash and 11 1 dash. So this was the apparent length of the radii corresponding to these 2 points. Now we have obtained the true length of the point of the intersection onto the true length O dash 7 dash over here. So this radii O dash 3 2 dash and O dash 11 2 dash obtained onto the true length. If we measure this distance and transfer it onto the slant generators O3 and O11 over here. So the 2 points of intersection 3 2 and 11 2 we have been able to identify over here. Similarly, corresponding to the points 4 1 dash and 10 1 dash, which happen to lie on the apparent length of the slant generators O dash 4 dash and O dash 10 dash. Now corresponding to the apparent location of these points, now the true length of the radii, they have been obtained onto the true length. So if we measure this radius O dash 4 2 dash, O dash 10 2 dash, so onto the slant generators O4 and O10, if we mark the same distances over here, points 4 2 and 10 2 we have been able to locate into the developed surface view over here. So the next 2 points, they happen to be 5 1 dash and 9 1 dash. So now once again, corresponding to these 2 points, true length of the radii we have been able to evaluate over here in the form of the distances O dash 5 2 dash, O dash 9 2 dash. So once we measure this distance O dash 5 2 dash and O dash 9 2 dash and mark these distances onto the true length of the slant generators O5 and O9. So we will be able to obtain the points 5 2 and 9 2 into the developed surface area. Next 2 points of intersection, they happen to be 6 1 dash and 8 1 dash. So once again, corresponding to these 2 points, the true length of the radii we have evaluated over here. So as we measure the distances O dash 6 2 dash and O dash 8 2 dash over here and mark these distances onto the true length of the slant generators O6 and O8. So the 2 points 6 2 and 8 2 we have been able to identify over here. Now the last point corresponding to the first auxiliary inclined plane, it is 7 1 dash. So point 7 1 dash already happens to lie onto the true length of the slant generator O dash 7 dash. So now we need not transfer this distance onto true length because O dash 7 dash itself is a true length. So we'll measure the true length of the radii corresponding to point of intersection 7 1 dash. So this distance will be O dash 7 1 dash and we'll mark this distance onto the true length of the slant generator O7. So all the 12 points of intersection, they have been appropriately obtained into the developed surface view over here. So now if we join all of these 12 points, so now the development corresponding to the auxiliary inclined plane passing through the leftmost corner of the base has been obtained over here. So now we need to obtain development corresponding to these frustum points over here. So we know that this is another auxiliary inclined plane which has intersected with the cone parallel to the horizontal plane. But here we haven't marked all these 12 points over here. Rather, we have marked only 2 points in this case. Why? Reason is simple, because we can check point 1, 2 dash. It is the point of intersection of the second auxiliary inclined plane parallel to HP with slant generator true length O dash 1 dash over here. So this radius will be true length radius O dash to 1 2 dash over here. So this radius will be a true length radius. Similarly, second point of intersection we have shown on to the other extreme, that is 0.72 dash has been obtained onto the true length of the generator O dash 7 dash. So this is again a true length radius O dash 72 dash radius over here. But corresponding to the 10 points which are going to lie onto these 5 pairs of the slant generators which are overlapping with each other, so we'll find that these will be the apparent lengths of the radii corresponding to the 10 points of intersection. So we cannot plot these apparent length of the radii which are obtained on the apparent length slant generators over here. So what we have to do, these 10 points, they have to be transferred either on the left side or on the right side. So they will be coinciding with the true length of the radii. They will be coinciding with either the point 1 2 dash or they will be coinciding with the point 7 2 dash over here. So we need not obtain any special or any different radii corresponding to a points of intersection of these 10 points over here. So that is why we haven't marked these points into the front view projection view over here, because ultimately the same radii we are going to use for all the 12 points corresponding to the frustum of this particular cone. So how do we obtain the development of frustum of the cone? We know this radius, true length, O dash 1 2 dash, which is equal to O dash 7 2 dash. So with O as the center, radius is equal to O dash 1 2 dash. We'll draw the simple curve over here. Why? Because corresponding to all the 12 points of intersection, the radius will remain the same, because this is true length O dash 1 2 dash, this is also true length O dash 7 2 dash. They happen to be equal. Remaining intermediate 10 points, they will be shifted either on left side or on the right side. So radius will remain the same for all the 12 points over here. So this way, this happens to be the development corresponding to the frustum of the cone over here. So we can now join the remaining uncut portion over here corresponding to the slant generator. This will be 1 2 dash and 1 dash over here. So here in the developed surface, we are going to join 1 2 with 1 over here. Here also we have joined point 1 2 with point 1 or with point 1 1 over here. So this way we have been able to obtain the front view projections corresponding to the truncated solid over here, the top view orthographic projections for this truncated solid, and we have been able to obtain the development of lateral surface of this truncated solid, which has been cut by 2 cutting planes over here. The first cutting plane happens to be an auxiliary inclined plane, inclined at an angle of 30 degree with respect to horizontal plane, passing through the leftmost corner point of this cone over here. And the second cutting plane happens to be auxiliary inclined plane, which happens to be parallel to the horizontal plane, so that we obtain the frustum of the cone by virtue of intersection of this AIP parallel to HP with this cone over here. So this way we have been able to obtain the development of the lateral surface of the truncated cone. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of development of lateral surfaces of the solids in the coming lectures as well. So thank you very much. Thanks a lot.